All right, so this is number 13, pre-cal 30. This is section 8.2, talking about log exponential equations, solving and different things like that. So 13 says, in a study, doctors found that in young people, the arterial blood pressure, P, in millimeters of mercury, millimeters Hg, is related to the vessel volume, that's V, in microliters, of the radial artery by the logarithmic function. So, as I explained to you just before, in science, in chemistry, and in nursing, medical fields, blood pressure and concentrations of different things all are mathematically based. So we have functions like this that all of our machines, your machines in the hospital, they all work on mathematical algorithms based on like log and exponential functions. It's quite common. So here's the volume equals, and you have this right here. Now, obviously, the pressure has to be greater than 56.1 in order for this to work. Why? Because we can't have a negative value that we're taking the log of. Remember, there's a domain issues for logarithms. Okay. To the nearest tenth of a microliter, predict the vessel volume when the arterial blood pressure is 110 millimeters. So, okay, so here we go. We have to predict the volume, so we don't know the volume, when the pressure, and this is going to be P minus 56.1, okay, when the pressure is 110, okay? So I'm going to take the P out there, and I'm going to make this 110, okay, 110. So this one's pretty simple. We're going to solve for P in a second, but this one's pretty simple in that we just have to evaluate this. So just with our calculator and stuff like that, no problem, right? So order of operations, though, please remember order of operations. I have an addition here, and I have a multiplication, and I have inside the brackets here, okay? So probably going to want to do brackets first. Remember, bed mass, right? So brackets first. So let's evaluate that brackets first. I'll get my calculator up here for you so you can see what's going on. On, clear, quit, clear. Okay. So 110 minus 56.1, okay, is 53.9. So 53.9, 0.23 plus 55 times log of 53.9. And we've done this first, so that's bed mass, that's good. And again, I don't have to go probably so slow on this. But what will we do next? We'll do this multiplication, or would we do this addition first? And of course, DM, division, multiplication come before addition, subtraction. So we have to do this next, right here. So we'll do that. So let's take the log of this first, I suppose. The log. There we go. Log of my answer is this number right here times 0.35. Okay, 0.606. So 0.606 and so on. So we're getting there, right? We're getting there. Now we simply just do this addition, leave all those decimal places, plus 0.23, and there we go. So 0.836. Volume is it says to the nearest what? Tenth. 0.836, so that's 0.8. And that's going to be millimeters mercury. Okay, to the nearest tenth of a microliter, predict the volumes. Volume. Wait. P pressure. Volume. Microliters. Sorry, microliters. Oh yeah, this little u there. It's the Greek letter mu. Mu, not meow, not a cat, and it's not a cow either. It's not moo. It's mu. Okay, so microliters. It's the symbol for micro, which is like 10 to the negative 6 liters. Okay. Okay, so 0.8 microliters. Okay, that's A. Now, to the nearest millimeter of mercury, predict the arterial blood pressure when the vessel volume is 0.7 microliters. So here's now in B, and I'll maybe change colors here now. So this was A. B. I'll do it over here. So B, we're now looking for P. So this is the point here. This was the big deal that I wanted to highlight here. So I kind of went through the whole question, but so now volume is given as 0.7. Watch this, 0.7. Okay, you don't need to use your units when you're doing the calculations, but you have to remember units at the end, right? So we're going to do this, 0.23 plus 0.35 times the log of p minus 56.1. So that's my original equation. And now this p is a little bit trickier to get to, right? We have to kind of peel away all the layers to get down to p there. But it's going to be a little bit of a challenge, and you'll see. So what we want to do is we want to subtract 0.23 from both sides. Okay. Oops. Oh no. Oh no. My numbers are disappearing. That means that this program's probably going to crash. I love technology. Okay, 0.7 minus 0.23. 0.7 minus 0.23 is 0.47. 0.47. Okay, that's gone. Now, now what we're going to do is divide by, okay, this is all gone now, divide by 0.35. 0.35. And that's going to be, we're going to be left then with log of p minus 56.1. Okay, so let's try and get through this here before my program crashes on me. So divided by, and again you can just you can just keep up the answer there, so you don't have to retype as many things. So that's 0.47 divided by 0.35 is 1.34. 1.34. Okay, now what do we do here? Okay, you can't just divide by log, right? We can't do that. We can't divide by log. This is kind of like when we're at the position with our sine, right? Sine of theta equals 1/2 or something like that. You can't divide by sine to get theta by itself. Here you can't divide by log to get p minus 56.1 by itself. Can't do that. So what do? Well, what have we been learning this chapter? We've been learning about the transition, or the how we rewrite a log equation into an exponential. Okay, that gets rid of the log. So I'm going to go the base here, which we know to be 10, to the power of 1.34 equals this argument here inside the log. So 10 to the 1.34 equals p minus 56.1. And voila, we've gotten rid of that log. We've liberated the p out of the grips of the log. Yes, it's free now. So we simply add 56.1 to both sides, and we have 10 to the power of 1.34 plus 56.1 equals p. So let's do that on our calculator, and hey, excellent, I've got this whole decimal. It's going to give me a very accurate answer, so I'm going to use that. And look at this, I'm going to also use my second function of log here, 10 to the power of, put my answer in there, bracket that all up, and add 56.1. Ooh, this should be, boom, 78.1 is what I get, and I think that sounds about right. 78.1 to the nearest millimeter of, so millimeters of mercury. Okay, now let's just double check that answer, and of course this one as well, the 0.8. Let's double check that as well. But we should be pretty close there. So let's just see what happens here. Let me just zoom out a bit so you can take a quick look at that. Okay, so those are correct, except it was noted here that B just asked for the nearest millimeter here. So it's just 78 millimeters of mercury. Okay, so that's how you do question number 13 on 8.2. Great question. You'll have to know how to do all of that, including solving for the p inside, which is the most important, maybe the trickiest part. Rewrite it if you've got log just on one side of the equation. If you've got log on one side. If you have logs on both sides, that's what we're going to do next section. So we're going to have to simplify that a bit differently. If you've got logs on both sides of the equation. But if you have a log just on one side of the equation and then just a regular number or something on the other side, then change it into an exponential, then you'll be able to solve.